Hi Calc 2 students. This is my first attempt at making a video, and you may catch me looking at my phone a bit because I'm controlling the GoPro with my phone. But you asked to get some feedback on sections 11, 8, 9, and 10, so I want to do that. If I have extra time, I'll try to go back and do some of the sections on the infinite series tests. But what makes these sections a little bit different is you've been learning a bunch of different tests looking at infinite series, which are sum of numbers, to determine does that sum add up to a finite number or not? Does it converge or does it diverge? What we're doing in 11.8 is something new. We're introducing a variable. So we now have an x in here. So a power series is an infinite sum where with coefficients cn and then factors x minus a to the n. A here is called the center of the power series, and if we wrote out some terms, C0, C1 x minus a to the first, C2 x minus a to the second, etc. So we've introduced a variable, and so if I can find an x that when I plug it into one of these a power series like this, that I actually get a finite sum, then I can actually call this a function. So we might get some new functions here for when these power series converge. And that will depend on the x value that we pick, and it'll depend, of course, on the coefficients. So we want to figure out, all right, given a power series, if and when it converges, for what values of x does it converge? When we know it does converge, then the question is that a function that we've already seen, or is it a new function? And then we can do some other games with it. In the next section, we'll learn how to differentiate and integrate. Because we love to differentiate polynomials. They're really easy to differentiate, and they're almost as easy to integrate. And so if I can take a complicated function and write it as an infinite polynomial, I can differentiate it and integrate it like a polynomial. That'll be the goal of the next section. So what we want to do right now is I want to work through a couple of examples to show you what can happen for a power series. It all depends on the coefficients. So the first example I want to look at is this. We'll take a look at the sum. I'll put it over here. Sum n equals 0 to infinity. I hope you can read this. Looks like you can. Of x minus 2 to the n all over 3 to the n. Okay? So if I wrote out the first several terms of this, when n is 0, well, x minus 2 to the 0 is 1, 3 to the 0 is 1, 1 over 1 is 1. So the first term is 1. The next term would be x minus 2 over 3. The next term would be x minus 2 squared over 3 squared, etc. X minus 2 cubed over 3 cubed. And I want to know for what values of x can I plug in here and I'll get a convergent series. Well, one x that always works for any power series, what number would be really nice to plug in here for x? X equal 2 would be really nice because that would make all of these terms up here 0. It would not give me just the first term, which is 1. And for any power series, a power series will always converge at x equal a, the center, and it'll always converge to C0. It's not a very interesting function. It's a constant function, actually a constant function valued at just one point. So if we plotted it, we would just get a point, the value C0 at the x value a. Okay? But we could have, this thing could converge at other values of x. The nicest tool you're going to get here for power series, ratio test is going to be your best friend. Because when you have something like this, and you take ratios of terms, a bunch of stuff cancels out. Okay? So remember, the ratio test says you take the ratio of the next term to the previous term, take the limit as n goes to infinity. When that limit's less than 1, you get absolute convergence. If that limit's bigger than 1, you get divergence. If it's equal 1, then you have to try some other test. Right? So let's try this for the ratio test. And I have this board at a slight angle to eliminate some glare, so it's a little bit funny to write on. So I'm going to look at the limit as n goes to infinity of the absolute value of the n plus first term, which would be x minus 2 to the n plus 1 over 3 to the n plus 1 over the nth term, x minus 2 to the n over 3 to the n. Okay. And you'll learn really quick to stop writing this step of the ratio test and just go straight to the n plus first term, x minus 2 to the n plus 1 over 3 to the n plus 1 times 1 over, or the flip of the nth term, 3 to the n over x minus 2 to the n. All right, that's it. So just go straight to that. That'll save you some time. And now we can see stuff that cancels here. N factors of 3 cancel, leaving just 1 downstairs. N factors of x minus 2 cancel, leaving just 1 upstairs. Okay. And so I wind up here with the limit as n goes to infinity of the absolute value of x minus 2 over 3. And what happens as n goes to infinity to absolute value of x minus 2 over 3? Well, there's no n in there anywhere. So as n goes to infinity, it just stays what it is. Absolute value of x minus 2 over 3. Okay. So the ratio test will tell us that this series will converge when that quantity is less than 1. All right, so when this is less than 1, we get convergence. When it's greater than 1, we get divergence. I'll just write div. Okay. When it's equal to 1, all bets are off. Could converge, it can diverge. We've got to investigate that separately. Okay. So notice that when absolute value of x minus 2 is less than 3, what values of x is that? Well, that's, if I play with that, let me come up top here. So if I think about absolute value of x minus 2 over 3 less than 1, well, if I multiply 3 by 3, I want to think what values of x is that. So that's absolute value of x minus 2 less than 3. And so this is centered at 2. So if I think about the number line, centering at 2, if I go 3 to the right of 2, that would take me up to 5. And if I go 3 to the left of 2, that will take me down to minus 1. All right? So this is my center. This turns out to be what's called the radius, capital R. That's the radius of my interval of convergence, R equal 3 in this case. Right? Because notice 5 minus 2 is exactly 3. Negative 1 minus 2 is negative 3. Absolute value is exactly 3. So between minus 1 and 5, absolute value of x minus 2 is less than 3. Okay. So for x is between minus 1 and 5, this series converges. Okay. For x bigger than 5 and less than minus 1, the series diverges, because this limit will be, this limit, absolute value of x minus 2 over 3, will be greater than 1. Okay. What happens at minus 1 and 5? Well, we have to investigate those separately, so let's take a look. I just erased my series, but I can remember it. Okay. So at x equal 5, we have the sum n equals 0 to infinity of, what was it, x minus, let me rewrite the series, x minus 2 over to the n over 3 to the n, right? That was my series. So this becomes, plug 5 in, I have the sum n equals 0 to infinity of 3 minus 2 to the n over 3 to the n. No, I'm plugging in 5. Sorry, I jumped the gun there. I did the subtraction already. 5 minus 2. Okay. But 5 minus 2 is 3 to the n over 3 to the n, but 3 to the n over 3 to the n is 1. What does the sum from n equal 1 to infinity of 1 do? Okay. Well, that diverges, right? One test would be the test for divergence. The terms are all 1. If I add 1 to itself infinitely many times, I'm going to get infinity. So this diverges. So at 5, we get divergence. What about at -1? So at x equal -1, we have the sum n equals 0 to infinity of -1 minus 2 to the n over 3 to the n. -1 minus 2 is -3. So this is the sum n equals 0 to infinity, -3 to the n over 3 to the n. But -3 to the n is -1 to the n times 3 to the n. All right, split that apart so I can cancel the 3 to the n's. And what happens to the sum of -1 to the n? Right. So that's when n is 0, I get 1. When n is 1, I get -1. Then I get 1, -1. Right. So the terms alternate back and forth between 1 and -1. When I add them up, my first sum is 0, my partial sums. My first partial sum is 1. My next partial sum is 0. Next partial sum is 1. Next partial sum is 0. My sequence of partial sums bounces back and forth between 0 and 1. That's not a convergent sequence, so this guy diverges as well. So this function, f of x equal to the sum n equals 0 to infinity, x minus 2 to the n over 3 to the n, is valid or converges, let me write it this way, converges on the interval -1 to 5. And notice I put round brackets because it diverges at both endpoints. And it diverges on the interval -infinity to -1, including -1 union 5 to infinity, right? So on this interval, -1 to 5, this is some function. What function is it? Maybe we can figure that out. Maybe we can't. But we'll come back to that towards the end of the video. Okay, let's look at another example. Let me put this guy up here as an example.